Hey, everybody. Today we're going to finish up our lesson on 5.3 and 5.4. So last class we talked about inverses and how the inverse of a natural log is an exponential. All right. We talked about the graphs of exponentials. We talked about how to solve exponential equations using logs and how to solve log equations using exponentials. All right. Today we are going to do the derivative of an exponential function, and we're going to do the integrals of an exponential function. All right, so we have a new formula here. All right, the derivative of e to raise to some power is e to whatever that power is, du, e to the u du. All right, so basically what you're going to do is when you find e to some power to find the derivative of it, you are going to, hopefully this reloads here. There we go. Good. You're going to rewrite the problem, and then you find the derivative of the exponent. All right. It's the original times the derivative of the exponent. You do not need to memorize this. Just to show you in the integral derivatives and integrals, here's the derivative. Derivative of e to the u is e to the u du, where u is the exponent. You rewrite it, then take the derivative of the exponent. All right. All right. Once again, we're trying to reload here. Let's see. All right. As this is loading, I'll pause this until it loads. All right, so for e to the 5x, so take the derivative. It's e to the u du, so you rewrite the whole thing. So it's e to the 5x times the derivative du is just, that's your u, the 5x. It's 5. So it's 5e to the 5x. That's your answer, e to the 5x times 5. All right. E to the x cubed plus 3. It's e to the x cubed plus 3. You rewrite it, e to the u, times what's the derivative of the exponent? 3x squared. And there's your answer. Just move that to the front. Even if you didn't move to the front, I'm still probably not going to take off. All right. You can just leave it just like that. All right. Now, rewrite this. E to negative 3 over x times. Well, how do I take the derivative of negative 3 over x? I can't do negative 3 to the x and negative first because then I would end up with 0. So I would have to do almost like a mini u du situation here, where if you have, all right, so this is negative 3x and negative first. Doing derivatives, getting integrals. Of course you do an integral of this. Derivative, sorry. So you put out the negative 1 times negative 3, so that gives you 3x to the negative second, right? So then you just move that to the front, and it's 3 over, all right, 3 over x squared e to the negative 3 over x. All right. Now, example 8, y equals e sine 3x. All right, so e to the u, which means I rewrite it, sine 3x times the derivative of sine 3x, which is sine, the derivative of sine is cosine. If you forget about that, you can just look at your formula sheet. Cosine 3x times 3, and just put the 3 out in front. You can leave the cosine 3x there. I mean, literally, if you just leave it like this, I'm going to accept it. Or you could put like the 3 there and move it there. And that's fine. All right. Any of those things are good. All right. Thing you want to remember is e to the derivative of e to the power is e to the u du. All right. E to the u du. All right. Now, obviously, you could have product, quotient, chain rule, that kind of stuff. They weren't here, but it's just all the same rules apply. It's just we have to do e to some power. You do e to the u du. Now, for the integrals of this stuff, it just gives us another thing. If you see e in the problem, something you can make u. Here we go again. All right. Sorry about that. It keeps having connection issues. Maybe I should make sure I pay my cable bill. All right. So it just gives us another way of putting u. So if we have e to something, we can make u whatever the exponent is. Doesn't mean it's always going to be that case, but it gives us something else to try, okay, along with everything else that we've done. All right. Now, the integral of e to the u du is, if you think about what it should be working backwards, hopefully you can figure it out. But if you don't, good thing. Integral up e to the u. There it is. E to the u du is e to the u plus c. It's e to the u plus c, which makes sense because the derivative of e to the u was e to the u du, which means the integral of e to the u du should be e to the u. All right. So if you see e, make u the exponent. So I make u 3x plus 1. Now it's all the same steps we've been doing. The derivative of that is 3 dx. I have to add a 3 because I need all of du to be there. So there's my du. I put 1/3 on the outside, and I am left with e to the u du. And then I just like, oh, well, that's just e to the u. So it's 1/3 e to the u, which is 3x plus 1 plus c. Done. That's all you have to do. All right. So I have 5x e to the x squared. Try u as x squared because that is our exponent of e. So u is x squared. Du is 2x dx. All right, remember, we can't add variables. So there's our x. There's our dx. All right, I don't need this 5, so I'm just going to move the 5 to the outside. All right, but I do need a 2. So putting a 2, so the 2, the dx, and the x, that's all my du. But to compensate for the 2, I need to put a 1/2 on the outside, right? But there's already a 5 there. What's 1/2 times 5? 5/2. So it's 5/2 integral. All the blue is gone because that's my du. It's just e to the u du, which is 5/2 e to the x squared, put the u back in, plus c. There's my answer. All right. So here I have some trig, but I have sine x e to the cosine x. Make u whatever is the exponent. The derivative of cosine is, if you forget, look on your formula sheet, negative sine dx. I have the sine there. I'm just missing a negative. So it's negative. That's all I have to put. So the sine x dx, that's my du. Integral of e cosine x, which is just e to the u du, which equals negative e to the cosine x plus c. All right. So now here we have a little situation. All right. I have two possibilities I can make u. All right. I can make u the exponent of e, or it could be the denominator. All right. Which one is it going to be? Well, if I make it just 3x, let's see what happens. If I make u 3x, I make du 3 dx, right? Well, I add the 3. There's my 3 dx. There's my du. I would get 1/3 e to the u over e to the u plus 2. That's not e to the u du. That's nothing I know how to take a integral of. So not going to make u that. Let's instead make u the denominator, right? Which we've done before. So we just have like this repertoire of all these things we can make u. We start off with inside of like a quantity, inside a radical, after a trig function, the whole trig function, we just did a denominator, and now we have an exponent of e. So it's all these of exponential. So it's all these different things that we can just try until one works. So I take the derivative of e to the 3x plus 2. 2 is just 0. E to the 3x, well, we just did this. It's rewrite what you have times the derivative of the exponent, which is 3. So I have that. Let me erase some of the stuff that is up here. Okay. So I'm going to add my 3 up here. And all of this that I just circled, that's my du. So since I added a 3, it's 1/3 integral. And I end up with du over u. Hopefully you remember what du over u is equal to. If you forget, it's right here. The integral of du over u is a natural log of the absolute value of u plus c. So I get 1/3 natural log of whatever u was, which in this case was e to the 3x plus 2 plus c. And there's our answer. All right. So, all right. So it's just all different ways. Here we go. Reload again. Let's see. All right. So here, basically, you have two possibilities. It could be the denominator of x squared, or it could be 1 over x. If I take the x squared, if I take the derivative, it's 2x. It doesn't really do anything with the exponent here. So what I'm going to do is I'm going to try it as 1 over x, which is the same thing as x to the negative first. So the derivative of x to the negative first is negative x to the negative second, which is negative 1 over x squared dx. All right, now, if I just put a negative 1 in there, look, negative 1 x squared dx, that's all right there. That's all of my du. So as long as I put a negative on the outside, because I need to put that negative 1 in there, all right, I have e to the 1 over x, which is e to the u. Everything else is just du. So I have e to the u du, which is negative e to the 1 over x plus c. And there is our final answer. All right. All right, here, same sort of deal. We have two possibilities. Is it going to be the exponent, or is it going to be what's in the bottom? Okay. All right. For right now, we're going to skip this one. We'll come back to this one possibly later. I just don't like the way it works out for right now. For just doing this for the first time, I don't want to confuse you guys. All right. So here, as this is reloading, hopefully, there we go. We have the situation. We got all this. This looks crazy, right? E to the 2x cosecant, e to the 2x cotangent, e to the 2x dx. Hopefully what you guys recognize is we have two trig functions. They're both to the same power. So what was the original thing we said when we first started doing that with trig? You take u is whatever comes after the trig. All right? So it's e to the 2x. All right? Hopefully this gets connection back again. And this would be du. Derivative of e to the u is e to the u du. So it's e to the 2x times 2 dx. All right. So, okay, I guess I have to do that again. E to the 2x, little magic trick. So it's e to the 2x times 2 dx. So I have e to the 2x. I have that. I just needed 2. There's my 2 dx. So I have 1/2 on the outside. So everything that's underlined in pink is my du, right? That's all gone. So what's left? Well, what's left is I have cosecant of e to the 2x, which is my u, cotangent u. And if I go check that out, what's the integral of cosecant cotangent? The integral of cosecant cotangent is negative cosecant u plus c. So it's negative 1/2 cosecant u. What was u? E to the 2x plus c. So it's negative 1/2 cosecant e to the 2x plus c is my answer. All right. So here we have x, e to the 2x, tangent e to the x squared. What is all? Well, we only have one trig function. What do I make u? Whatever comes after it. All right. So just because we see e doesn't mean you always make it the exponent. And you would see if you made it x squared, you wouldn't have anything that would be easy to take an integral of. So let's make it e to the x squared. All right. Take the derivative of e to the u is e to the u du, which means I rewrite it and then times it by the derivative of the exponent, which in this case, derivative of x squared is 2x. Put the dx on there. All right. I have x, I have e to the x squared, and I have dx. I'm just missing a 2. So now I have it all. 1/2. All this is du. And what am I left with? Tangent u. So I'm left with 1/2 tangent u du. What's 1/2? What's tangent u du? Well, let's see. Let's look. Go to my sheet. It's right there. It's negative natural log of cosecant u plus c. So the answer is negative 1/2 natural log of cosine u, which u is e to the x squared plus c. All right, so we are just continuing to build off of what we've been doing with derivatives and integrals, especially the integrals, and all these different ways we can use substitution. All right, so now we just added something to our weaponry here, things we can use, our arsenal, I guess you want to say. And we now can make if you have an exponential, we can make it the exponent. All right, just because you see e in a problem doesn't mean it always is. You still will use some of the other stuff. All right, so you guys will have some practice with this. And your next quiz, which will be a partner quiz, will be just on these two sections of notes. And that won't be we'll do a couple of days of review before you end up taking the quiz. All right. That's it for today. Hope you guys are doing all right. Stay healthy. Talk to you soon.